I've got our 348 up here on the boring machine, and in the last video you saw that we had measured two of these cylinders, and this cylinder we have some pretty significant rust, this cylinder we have some pretty significant wear. So more than likely both of those are going to get cylinder sleeves installed today. Cleaning guy is over there grinding a crankshaft, so there might be a little bit of background music for you. But again, this is where the W series is kind of a unique engine with this angled deck surface relative to the cylinder bores. So normally when we're set up here with the cylinders up, straight up and down relative to the machine, the deck surface is also perpendicular to that. But in this case, it's at a slight angle, so it doesn't really look right on the machine. It kind of looks like we're about to bore this block at an angle and completely screw it up. But you can see we've still got our normal triangle set up down in here, referencing off of the pan rails and the mains of the block, because the cylinders are actually still 90 degrees to each other, just like your more traditional V8 engines. So right now I'm getting centered up on the rusty cylinder, and I thought we'd put a cutter in and cut this cylinder as if we were going to try to go straight to 40 thousandths oversize and show you guys what the rust looks like after going that far. We have this little centering finger here. That's just what I call it. I don't know what the technical term actually is. That is connected to a dial indicator up here on the top of the machine. We basically turn the machine on here and you can see that that's wiggling. Now, if that were a perfectly round surface that we were perfectly centered on, that needle would run completely true. Obviously, that's not really the case of what we're working on. In the case of this cylinder, it's pretty rusty and just kind of a mess, plus there's wear from the piston, so that's not running exactly true. I'm gonna go ahead and turn this off though, and just to kind of prove to myself that we are straight up and down, I'm gonna run that indicator to the bottom of the cylinder real quick. Hopefully this other camera will pick up the dial indicator throughout the travel here. And what I'm hoping to see, at the top of the cylinder, there's going to be a lot of piston wear, so that needle is probably going to move. But by the time we get to about halfway down, I'd like to see that needle stay relatively still, because that would be a good indicator that our fixture is getting the block straight up and down. And it looks pretty dang good. Now, usually we could either center up above the piston ring travel and get a good idea of where the cylinders were from the factory. If we're trying to save a block at a smaller undersize, we might even center directly under the piston ring travel where it's worn the most, because you may have to actually purposely bore it off center to save a block at, say, 20 thousandths versus having to go to 40 thousandths oversized pistons. In this case, I think our best bet is actually going to be centering at the very bottom of the cylinder where there is the least amount of wear, and that'll get us close to where these bores were from the factory. It's a little scary. And right there you can see we're pretty dang centered. That's about as good as it gets with this needle. So I've got the table locked down, and that's where we're gonna do our boring. Just for fun, I'll bring it back up here. Maybe we'll center about right there. Yeah, we've got wear plus the rust throwing that needle off. So our stock bore size for this engine is 4125. So I'm just gonna pretend like we were boring this 40 thousandths oversize, which would be 4165, which would be right there, but we always leave a few thousandths for honing. So I've got my cutter set to 4110 and a half-ish, 4111. And we'll just start cutting the top of the cylinder there and see what it looks like. This upper part of the bore, the combustion chamber part, should be bigger than what I'm cutting to right now. But just in case, I'm gonna feed it by hand. So far, so good. I'm just gonna let this run down about an inch. Look at all the rust, the dusty rust coming out. I hope the camera can pick that up. And just checking here with the bore gauge. That left us about 4 thousandths to hone, 4161. So that cutter cut right where we wanted to. And look at all that rust still showing through. And we're not even to the worst part of it yet. So there is no way that would clean up at 40. And I pretty much guarantee we would still have rust at 60. For fun, while that cutter's set up at the right size for if we were gonna go 40, I wanna come over to this cylinder that we know has so much wear and just see if maybe by chance it would clean up. Let's just see how far off that is at the top too, actually. Pretty far off. I'm gonna center up based on the wear, because if you're trying to save a cylinder at a smaller oversize, you kind of have to set up based on the wear, because the cylinder does not wear perfectly on center. So let's see how much we have to change things. And it may just be not round. So that's as good as that's gonna get on a worn cylinder. If I end up putting a sleeve in this, I'm gonna center off of the bottom again. But I just wanna cut that upper inch and see if it even cleans up. Doesn't sound very even. Yeah, see, there's so much wear that it's not even cutting now. And there it came back in a little bit more. So hopefully this will show well enough. But this part up here, up to that line, that all should have cleaned up. And I should have put some Dicam on there, but you can see it cleaned up over here, but it did not clean up over there. And that's because they used a ridge reamer on this and cut it funky. Then this darker area up here, right there, that line is where the piston ring travel comes to. And you can see it did not clean up there, nor did it clean up on the opposite side of the cylinder. So overall, this cylinder was not going to make 40. It definitely would have had to go 60. And I think our best case scenario is to put a sleeve in it. So by the book, for these sleeves, I should be able to bore the hole to exactly 4.3125 inches, and that'll give us the correct press fit to install this sleeve. Now before we do that, before we do our final cut, I'm actually gonna measure these a little bit closer and double check that to be sure. But I've gone ahead and we're gonna do this in 3 steps. I'm gonna do about an 83 thousandths cut, and that's gonna bring us to 4208-ish. I'm gonna do another 83 thousandths cut. That's gonna bring us to 4,291. And then we'll do our final cut, which I haven't set up yet because I don't know exactly what it's gonna be to get us the correct press fit for these. So I'm centered back up on cylinder number 1. I have my depth stop set up so that hopefully we'll leave about 1/8 of an inch ledge at the bottom of the cylinder for the sleeve to press against. And should be ready to go. Okay, cutter number 1 is in. Now this should probably cut at the top here. I think it will. So again, I'm probably gonna feed part of that by hand. Probably run about 420 RPM. I bet the cutter likes that cut. Now it's just a normal cut. Okay, I'm gonna go eat lunch. Okay, let's hit it with cut number 2. Pretty hot. I think I'm gonna let the block cool for a little bit. We've just got our final cut left here, and just for fun, I wanted to sonic check this cylinder and see exactly where we're currently coming out on thickness. 120 there, 125, 160 or 170, and 130. 30 more out of this roughly would get you to standard 409 size, but that would take another 15 off there, so you'd be right at about 100 thousandths on the cylinder wall thickness, which I don't know. I don't think I would be comfortable running it that low, especially with not knowing what the backside of the cylinders really look like here as far as rust. But overall, you know, maybe it could. So after measuring a few spots on each of the sleeves and taking an average across the sleeve, because, you know, in shipment and everything, they can get a little bit distorted, but once they go down in the hole, you know, they squeeze out to the right, you know, the right dimension and everything. This one we're measuring 4.3158. This one we're measuring 4.3153. For our press fit here, I really would not want to see anything less than really 1.5 thousandths, but definitely not less than 1 thousandths interference fit. Same thing as you start going above 2.5, you know, it's gonna start to get difficult to put in, and anything above 3, you're really gonna have a rough time. So that being said, I think we're gonna shoot for 1 3/4 thousandths press on this sleeve, and we'll shoot for 2 1/4 thousandths press on this sleeve, since we do have 0.5 thousandths difference between those two. To get there, our cutter needs to be cutting the bore to 4.313 and 6/10 basically. So I've got this set just a little bit smaller than that, because I know that this cutter seems to maybe be cutting about between 0.5 thousandth to 1 thousandth bigger than what we set it here on the mic. So that would theoretically put us in that correct press fit range. So we should be good to go to do our final cut. This is kind of your classic measure twice, cut once type situation. So Hopefully all 2 times that I measured were right. They make bigger sleeves, right?
Yeah.
No. Not yet. And this is for the smaller sleeve, so we'll have, I think we're pretty dang close, 1 8/10 press on that. And with the sleeve that's a little bit bigger, we'd be, 2 3 or 2 1/4. So I think we're kind of right where we wanted to be, honestly. So now I'm gonna move over and repeat the process. Cutter number 1. Cut number 2. Okay, I'm gonna let that cylinder cool down before we do our final cut. So let's find number 3. And it appears to still be correct. About the same. So at this point, number 2 and number 8 are both bored out for the correct parent bore size to install our sleeves with the press fit. So we're gonna get set up to do that, and we'll be right back. So we're always trying new things here in the shop and, watching other people's videos to get ideas. And I don't know if you sent it to me or I sent it to you, but there's a guy, Paragon Engines on TikTok, and he had actually a hydraulic cylinder set up that he would use to pull a sleeve into a block, rather than the option of banging on it with a hammer that always gets people excited.
Yeah.
And we do like sometimes doing the temperature differential option, but what people don't understand, and no matter how many times we say this, they still won't understand, is when you drop that cold sleeve into the hot block, as the temperatures equalize, that sleeve comes up off the bottom of the counterbore a little bit.
Yeah, you've dropped it in, it's all the way down, bottomed out, and when the temperature equalizes, that sleeve grows.
And it pulls it up away from the, the step that we've put, and it just makes us nervous that down the road it would move.
Right.
That's why we put a step there, is to keep the sleeve constrained on both sides, up and down. Realistically, the press should be enough to hold it over time, even if you didn't put a step, but we've all heard stories of sleeves dropping when they didn't leave a step.
Yeah.
So we do have the step, but we're gonna get this set up here, and hopefully this will make it pretty easy to put these sleeves in, because we've got the weird deck angle to deal with, but I think this will go pretty smoothly.
Yeah, I'm looking forward to it going smooth anyway.
Are you thinking our normal Loctite at the bottom of the cylinder, oil at the top of the cylinder, oil at the bottom of the sleeve, and Loctite at the top of the sleeve?
Yeah.
And then
Push it together.
send her home?
Yeah.
Okay.
You can do it. You want to get this out of the way?
Sure, if you want. It's
Until
screwed in on the bottom.
Here we go.
Okay. And that's retaining compound, and it'll seal it if we did happen to have a water leak behind the sleeve. But I think these walls are actually thick enough still that...
We'll never have a water issue.
Not in this lifetime, anyway.
You want me to put a little band of
Press fit lube?
press fit lube around the top here?
Yeah. It's a really light band. It's not...
Well, seeing as how it's a press fit, anything more than a light band is just going to scrape off anyway.
Yeah.
Put that over it.
This cylinder. Tell me.
Yeah, and aren't you centered down here?
I made this 2-inch bar the other day. I mean, I didn't really make it. I just made the ends nice and drilled a hole and milled a flat on it here. So on the bottom side, we've got a nut and that's just pulling on the mains of the block. And then on the top side here, goes through the sleeve, through a driver here that the jack, do you call it a jack, or what do you call it at this point?
Just a ram or
Cylinder.
Yeah.
That the cylinder sits on, and then through threads up top.
Yeah, pretty simple setup. Just run it down, what, maybe 2 inches?
Think
Our
back
cylinder only has 6 inches of travel,
Yeah,
and we're gonna need,
dang near 6 to...
yeah, it should be enough without having to reset. But let's go down a couple inches and then tighten everything up and then go the rest of the way home from there, so we don't run out of cylinder about the time we get into Loctite.
Yeah.
And start out real easy and make sure this thing is going square.
What do you think?
A little bit more. Okay, maybe let off of it just a little bit.
So
I would say go again. I think.
About there?
You can go a little bit more. Maybe go till we're almost to the Loctite. Yeah, let's stop there. And
That's awesome.
yeah,
That works so good.
we're not there yet.
I think we're gonna get there.
I'd say that's pretty good right there.
Okay.
Send her home. Getting tight.
There it is. What?
Give it a couple. That's enough. There you go. Let it sit for just a little bit.
Okay. I was starting to worry that we were going to be closer here than I thought we were, and that...
Well, I started thinking about that too when you first started going there, and I remembered that the sleeve was enough longer.
Well, I was just like, the cleaning guy ordered these sleeves, and I never checked the length on it. So, what are we running into here? That worked. That worked really well.
Yes.
That's
the
so much less stressful than the liquid nitrogen too.
Yes.
The nitrogen is sketchy stuff, and man, if you drop it in and you only get it halfway before it tightens up, you got to hammer it anyway. And
yeah, I don't think people realize
how dangerous
that can be if if you'd accidentally spill it or drop some down your shoe, or
yeah,
all kinds of things could happen. Plus, maybe in some areas it's easy to obtain, but not for us when we're darn near 15 miles from town.
And our doer doesn't. Is that what it's called?
Doer, yeah.
Yeah, our doer doesn't keep.
Or our doer doesn't.
Ready?
Yeah. That was a good idea.
To steal that from that guy on TikTok.
That was a good idea to steal this idea from the other company. We appreciate you. I think that's probably one of the nicest sleeves we ever installed in the last 40 years.
I don't know about that.
Well, we used to use, when we had the old Van Norman portable boring bar, and was boring blocks with that on the little stand. In fact, that's when my dad was boring blocks for us yet. We had a jig set up to where he just put a hydraulic jack on there with a chain down over the top, through a couple of cylinders, and pull the sleeves down the end. That always worked real well. Awful lot of sleeves we've just driven them in. Never had any issues because of it, but it didn't maybe necessarily look as professional as it could have.
Yeah. Okay, let's get the other one set up and...
Because everything we've got here is highly accurate. Let me check it. Let's reposition.
I don't know that it's necessarily a time saver.
But it's
the other thing I don't like about doing the temperature differential is you can't go straight back to the machine.
No.
You have to wait for that block to...
It has to come back to room temperature again. Well, it's certainly not time waster.
No, it's not wasting anything.
It's not taking any significant amount of time to do this. Give it just a couple more. There it is. That is just pretty slick.
That works very, very well.
Yeah.
Before we go back to the machine and actually deck the block, I've got the old head gaskets on here in case I slip up, but my plan is to try and grind these down quite a bit closer to the deck so that it's not as big of a deal on our other machine over there trying to deck the block with those sleeves sticking up.
And at this point, I'm going to go ahead and rough bore for our 40 thousandths oversized pistons. I've mounted the block the opposite direction of the way I originally had it, because even though the customer is not concerned about the numbers on the deck of the block, when I surface this engine, I think I am going to go ahead and be careful to not cut those off, just in case if he ever wanted to resell it or anything like that. Might hold some more value if it did have the suffix code on the deck of the block still. I'm going to center up at the bottom of the cylinders where there's the least amount of wear, because again, at the top, at some point in a previous life, somebody used a ridge reamer and cut out the ridge on these, so I can't center up above the travel, and there's enough wear there that I think my best shot of getting these bores back where they should have been is going to be to center up at the very bottom where the piston ring does not travel. We're going to rough bore to maybe about 4/160. I've got the cutter set right there. Should be a good spot. Let's just go down the line and then we'll go back to number one. The sleeve is a little bit undersized from our standard bore, so I've got a cutter set up to take it to what would be standard bore size for this block. Rough bore for our oversized pistons. So now I'm going to cut the counter bore in the top of the cylinder like these have here that makes the chamber section. Looks good. So if you watch our videos, you know that normally at this point I would switch over to the surfacing head and surface the deck of the block, but since it's gonna end up being a totally different setup anyway, I think for now I'm just gonna switch over to the other bank of cylinders and rough bore those, and then we'll move on to the whole decking situation, plus the fact that we have to figure out how to put these cutouts back in the top of the two cylinders with the sleeves. Pull our triangle out of there. It's okay, this side should be simple. Now the only thing I'm not sure about on this side is down there in the bottom you can see where when they bored it at the factory they cut into that main webbing a little bit. And that's actually, I think, the oil galley. So I probably don't want to cut that any more than I have to. but I need to make sure that I need to cut down as far as I can so that I have clearance out the bottom of the cylinder for the cylinder hone to overstroke later on. I put a brand new cutting insert in here as well, so hopefully my size is still okay and everything will cut a lot nicer. Wow, that is an amazing surface finish. And look at this. I don't know if I've ever seen one be that close to cleaning up and not clean up. Maybe 3 in that one spot. So when we talk about one not cleaning up or leaving a shadow, I don't know how well the camera's even gonna pick this up, but that little sliver right there is a spot where the cylinder has more wear, kind of that direction. It's in line with where the exhaust valve would be, so I don't know if that has anything to do with it or if it's just coincidence. And then over here, this is actually above the ring travel. It didn't quite clean up, but that's from where the last person used the ridge reamer and cut the ridge out of the top of it when they did a re-ring on this. Luckily, this spot here that is in the ring travel, I can't even feel that with my fingernail. I know that'll clean up because we still have over 4 thousandths to finish out here in the cylinder hone. So that'll clean up and we'll be good to go. That new cutter did so good on this though. So much better finish than these. I think when they cut the counterbore on this side, they were off a little bit. Because I caught this after the fact, and look at the chamfer there. There's a whole bunch on this side, but almost nothing there. Same thing here and here. Almost nothing on this side, whole bunch on that side. So I may have to do a little bit more here. I gotta think about it. I don't know. This thing's kind of weird on this side. I've made the decision here, just kind of talking back and forth the cleaning guy. What we're worried about is our hone. It's going to hone weird here at the top with the way that cut, you know, all the way over here. And we may end up in a situation where we don't have enough clearance at the top there to get our piston to go in the hole. I don't think that would be the case, but what it looks like here, based on the way these other ones are coming out, is the counterbore on the top was done in a separate operation from boring the cylinders, and they were shifted, you know, maybe, I don't know, 20 thou, maybe a little bit more to that direction towards the back of the block when they cut the counterbore. So what we're ending up with is no chamfer here, basically no offset on that bore. It's supposed to be, you know, that counterbore should be centered on the cylinder, but it's not. So I'm going to put the cutter back in that I cut the top, you know, section on these 2 sleeves, and on this bank of cylinders, I'm going to go back in and I'm going to cut that. It's not going to, actually, it's definitely probably not going to clean up all the way around the cylinder, but what it'll do is get us our clearance on that side. So it may not look the prettiest, but I think it's going to work out. This is the category of working with what you've got, and we may not end up with perfectly identical combustion chamber volumes across all 8 cylinders on this, but the reality is it's almost certainly not enough that it'll ever be a problem though. Don't you guys like that look a lot better than this? I mean, there's almost no chamfer there, and here we'll definitely have that clearance for our pistons. It actually cleaned up clear over to here, so farther than I expected it to. Let's move over and bore that last cylinder, then we'll come back and cut the top on those two. Oh no, I didn't record that. Okay. Well, I went in and cut it.
Now we're gonna deck the block. Since the deck is at a weird angle, we can't use our triangle that normally we use to fixture the block square. So I just have a little standoff on this side supporting the block. And what I did here is put our level on here and kind of checking various places. Pretty dang good. Pretty dang good. Just kind of trying to split the difference or find an average there. But I think we're pretty well square. So now I need to switch over to our surfacing head. Make sure this is pulled out. I'm gonna go ahead and put the safety in there so that we can't accidentally auto feed. This is the easy side, so we should be able to just deck it to wherever it cleans up. I'm gonna run this cutter close over here. This is a cutter from a company called Performance CBN, but that's just a little CBN cutter. This one's actually really designed for harder blocks, like like diesel type cylinder heads and blocks. It's not gonna hurt anything to use it here. Okay, so now I'm just using a feeler gauge to run it down close, so now it just barely touched right there. So now I know we're within maybe 0.003 of touching. And I'm actually gonna go up a little bit just to be safe. Turn the spindle on. We'll run full speed, 630 RPM on this machine. Slowly traverse over. You're right there. It just barely heard it touch. You can see two spots there that it skimmed. See those two shiny spots? That's where the cutter just barely skimmed across the deck. Let's do like a 1 thou cut. I'm gonna zero it right there. We'll go down 1 thou and we'll just run across just for fun. See what the deck looks like. See how square we are. So it cut a little bit heavier towards the front of the block. Actually, dang hair cleaned up all the way across. But here on the back, you can see some funny machining marks from the way it was decked at the factory, or I assume at the factory. You can see the factory cutter was kind of bouncing a little bit. It almost looks like it left those kind of wavy marks through there. But man, we're getting a nice finish on here. Probably another couple thou and we'll have it. That looks nice. So we took 4 thousandths total off the deck. So -4 on our z-axis on the digital readout. Theoretically it'd be nice if the opposite side cleaned at that same value, and that would mean that we were at the same deck height. Okay, so I've got, again, a little jack stand on that side, a little jack stand on this side. I decided to add just because the way that the cutter is pushing this direction, I wanted to make sure that the block couldn't tip over this way. I highly doubt it would because all of the weight is still on that side. So just having that jack stand should have been enough, but I added this one just to be sure. And you can see there, we're a little bit high on the inboard side. If I come over here, we're maybe a little bit high on the outboard side. So I think we've got a good average here to make our cut. Now this is a side that's a pain in the butt because the first thing I got to do is rack my cutter, cutting these down to be even with the top, even with the deck surface. And then the other thing I was going to try to do is save the suffix code here on this block, save the numbers. Customer doesn't care if I cut the numbers up, so if I screw that up, it's not really a big deal, but I just thought, you know, let's try to do it as if we were doing a proper restoration. Okay, well, you try to do what you can. Sometimes you got to work with what you got. Because of the way this machine is designed, the cutter on this actually is tilted ever so slightly so that this side of, when the cutter comes around on this side, it's lower than it is on this side so that it doesn't, so that the cutter doesn't cut on the back side of the pass and make a, you know, make an ugly mark or whatever. That's why I had to put the block with the front facing this way so that we could run this across and stop here before we cut the numbers off. But because of the design of this block, I can't move far enough over this direction because the other bank of cylinders is going to hit the machine if I move any further that way. And what that means is we would want to stop about right there if we wanted to save the numbers on this deck. The problem is you can see that because of the curvature of the cutter, we would leave this whole corner over here unsurfaced, which obviously is not going to work. It would cause the head to sit up on that side. Gasket probably would not seal. It'd just be a bad day. So what we're going to have to do is surface on over this far. And at that point, the numbers are gone. Luckily, this customer doesn't care about the numbers. It's going in a vehicle that is, I think, 2 years older than the first year that they even made the 348. So there's really no value for the customer in having the numbers. I just thought it might be a good thing to keep just in case the customer ever had to go a different direction down the road and maybe wanted to sell the engine. It might be more valuable to somebody if it did have the numbers, but we got to work with what we got, and what we've got is interference on the machine if we try to save the numbers. So we're just going to go ahead and deck them right off. So this part is going to suck because I have to cut these sleeves down and they're jagged edges right now, but we got to get them closer to where the actual deck surface is. So this will be kind of a manual process. God, I hate doing this because it's right in my face too. Figure out where our deck surface actually is on this side. Okay, so we're actually 12 thousandths higher on this side. Okay, so that last pass there before I went to eat lunch, It's probably going to be a little more difficult to tell because I didn't have color on the block yet. But you can see the cutter went across here and here just a little bit. It went across right here in the middle just a little bit. And out here on the end, it cleaned up here and it touched over here. So I'm going to say the block is fixtured pretty well, you know, to what that deck was cut the last time. Now on the digital readout here, if we go to -4 thousandths on our z-axis, we should be at the same deck height as the opposite bank of cylinders. Oh, I don't know. Maybe we'll do a 2 thou just for fun to see what it looks like. I guess it did a little bit more than I thought. Really bad factory deck surface. You've got waviness all across here, wavy here, wavy here, wavy here. They're still there right now, but they won't be by the time we finish. Since we've decided that we're doing this as a performance build and not worrying about restoration numbers, we're going to go ahead and take this on down to -4 on the digital readout, which will get this to the same deck height as the opposite bank. So we should be able to do that in about 2 more cuts. I did a little bit of deburring on these 2 sleeves too. It looks actually really nice. Now the last thing left to do here is see the notches that we have by the exhaust valves. I got to cut this notch in and I got to cut that notch in. Problem is, again, when I have it fixtured this direction with the front towards us, I can't move far enough over to get in line with the spindle. And actually, even if I flip the block over the other way, I still can't get far enough over to cut those notches. So I have to completely change my setup to do this. I know there's a lot of people out there that are going to say grind it grind it by hand, but that's just not my style. All right, so I've never used this fixture for a block, so I had to get cleaning guys' help from...
And it's been so many years since I used this fixture.
It was kind of tough to figure it out.
Just digging through the cobwebs, remember all the pieces that you have to use to set it up.
So it's still supported off the mains to get us straight, this way.
Right, straight this way.
We essentially did the same thing as we had on the other stand with a kind of a jack stand on this side. And then we took a long time to try and dial in the block to make sure the fixture was on the machine that way.
Square this way.
And we think we got it good to go. So then explain what you've been doing here.
Because
we need to cut a right-hand notch, or I'm going to call it right-hand, it may not actually be, but from looking at it this way, a right-hand notch on this cylinder that we put a sleeve in, and a left-hand notch on that side.
So while you were grinding a cutter that we hope will duplicate this angle in here, I spent a bunch of time here running a cutter down into the bore here on this existing cylinder. And where did my little piece of paper go?
I don't know.
Basically just using this is a lens wipe, but just a piece of paper between the end of the cutter and the side of the bore of the block up there in that cutout, and just feeling for where the side of that sleeve is, so we can try to center up on how they bored that valve relief in there.
Yeah. So this cutter is adjusted to 3-inch diameter because as best we can tell...
As best we can tell, this has a 3-inch diameter or 1.5 inch radius.
Yeah.
When they bored this in there. So I set the cutter up. I'm probably a couple thousandths shy of that just because I didn't want to actually be touching anywhere while we're doing this. And there's not a whole lot of science to what we're doing there. It's pretty much just by feel, hit and miss, because we have no way to dial in off of the block itself. We just have to try to match what's there.
Yeah. But at this point, you've centered the X and Y axis for the 0 point of that notch. And you've centered the Z, or zeroed the Z axis for the depth we need to cut to.
Right.
The cutter that's in there right now is just a flat cutter. So then we'll come back in. I already lost it. With this cutter that I've ground with a 60-degree angle. And I don't know if that's exactly the right angle, but it looks pretty close to me.
Yeah.
So it's not the prettiest hand ground cutter, but I think it'll do what we need it to.
Should do what we do.
And I may have to do that in 2 cuts, but we'll see what it looks like after the first one. Now that you've got that dialed in, and we're going to have to do the same thing over here, I assume?
Yeah.
Okay. Yeah, so that's going to take a little bit of time, but we're going to move over the bore spacing, 2 cylinders worth of bore spacing, so 4.840, right?
Yes.
Times 2. And that should get us in the right spot here to cut that counterboring.
And I think we'll back that cutter off maybe 20 thousandths
to start.
And let's sneak up on it.
Okay. 4.84.
Times 2 is 9.68.
Okay.
You know, I'll never get that exact. There it is.
Lock it down.
Okay. And I want to back that cutter off a little bit.
Looks right from here. It really shouldn't touch the block. It really shouldn't until we're to the next size. Yeah. But even if it skims it a little bit, I'm not worried.
Yeah, it's not going to be a big deal with where that's at if it did skim the block a little bit. But if our bore spacing is right, I think we're going to be pretty close. Okay, just eyeballing that, doesn't it look like we're inside back here and here?
Yeah.
Of where it was originally?
Yeah. And when it's all said and done, this may still require some hand trimming or, cleaning up, deburring, I don't know what to call it.
Blending.
Yeah.
I think 0 will be right.
I don't know if it will be, but it should still be, actually.
16, 15, 14, 12. Are you watching it?
That's 0.
Okay. I think we should come up out of there and open that cutter up just a little bit more. Make another pass if things are looking like we think they are.
Yeah, we'll have to decide what we want to do with that thin edge of that sleeve.
Yeah. Yeah,
But
have some mixed feelings about that thin edge sticking out there, but we'll deal with that after we figure this part out. All right, cutter's adjusted to exactly 3 inch. In we go.
It's breaking part of the sleeve.
Go easy with it. Are we touching the block anywhere?
Are we touching the block anywhere?
Yeah, like here or there.
It's hard to say. I think we might just barely be skimming the dust off of it, honestly.
Okay.
What do you think?
Well, come up out of it and let's take a look.
Man, I don't know what to do with that thin area of sleeve.
I say we adjust that out 5 thousandths more and see what things look like.
Okay, we're trying 305. Yeah. A little heavier on that side than that side, but
yeah, that's just exactly what we wanted.
okay. So let me figure out this other cutter. Okay, so now we've got our cutter that may or may not make a mess of everything. With that being a 90-degree bottom cutter or whatever, I don't know what to call that. Our setting mic doesn't really work for that, so.
Yeah, I'm questioning your radius on there.
Too big?
Yeah, don't know why we have that.
Because it has a little bit of a nose radius to it.
Okay. Okay, now we're not cutting too much, are we?
I don't even.
Let's put some blue on it. Some Prussian blue, Prussian red. I think you're going to get it all over our machine.
Why does it matter?
Okay, you're cutting on the sleeve. Are you about there? You're there.
It literally just cleaned that up.
Huh. Man, that matched that perfect.
Wonder who ground that cutter. Okay, so it left a little bit of a flat.
Oh.
I could grind that bigger too, I
Well,
guess.
that would probably be the way to do it, would be go ahead and grind that one a little bit bigger and then come back and...
See if it'll clean.
Yeah.
I didn't grind this clear across. There's a flat on it, and that flat stayed there on the sleeve rather than being like these.
Touch that again and you'll have it. And then the only thing left to do is figure out if we think where this edge of that sleeve comes out to a tapered point is going to be an issue.
Yeah. Sharpened that a little bit more. That wheel on our sharpener is pretty fine. Takes 15 years to sharpen, so that
Well,
wasn't...
that kind of sucks.
What? Use the other one.
The other one.
Yeah, there's a... The other bottle
That's
is over
okay
there.
to do this, isn't it?
What? Yeah, do it.
To blue it with the red?
Do it.
Next time, you need to buy your applicators somewhere besides...
Don't... What the f*** are you doing?
I was thinking
You weren't thinking is what you were
I
thinking.
didn't want the diameter to fall out of the lid again, so I was going to put the bottle over the top of it.
Jesus. Actually, that's the reason that we put it in the little bottle, is so that when you spill it, you spill that much, not this much. Jeez. Okay.
Okay, is that dry? Blow on it a little bit.
It's dry enough.
That would have been a good one. You ready?
Yeah. So it might skim again, depending on how much the tool was deflecting.
Okay, you just
Touched my sleeve.
Yeah. Okay, you're there. Back off.
It's fine. 217. Remember that for the other
And
cylinder.
you still left a little tiny edge.
No. Well, I'm out of time for today,
Okay.
so we're gonna have to.
This can sit here for the weekend till Monday.
It'll have to sit here, and in the next video, I'll start with cutting this notch. I'm gonna have to grind this cutter just a little bit more, but my fingers were hurting trying to hold it on there.
Let's call it for the week. Go have some fun somewhere else. And pick up here on Monday again with a new video.
Tell me that's not some good machine work.
I'm pretty impressed with how that's coming out. Yeah, I'm real happy. I mean, we've got some time involved here, but it looks very professional. I have to pat myself on the back, pat you on the back, that what we're doing here looks very professional.
Okay. Pick it up on Monday.
Okay.
Go buy a t-shirt.
Yeah, we still got shirts for sale.
Okay.
See you guys.